Hello viewers, welcome to my channel. I am Hasham. Now I am going to start the problems on correlation analysis. Last video I have completed the theoretical part, the meaning of the term correlation and what is the importance or significance of correlation. What are the methods of calculating correlation? What are the types of correlation? All these things I have explained in the last video. So before watching this video, I expect my viewers first of all to be acquainted, to be clear in mind regarding why we calculate correlation. What is correlation? It is a statistical technique which expresses the relationship between two variables. There are many cases where two variables will have some relationship. So to study, to analyze the behavior of relationship between two variables, we apply the statistical technique called correlation. Simple example I have given, like advertisement and sales. They have relationship. Normally more advertisement will generate more sales. Similarly, more income of the people will give rise to more investment. A good rainfall will give you more agricultural production. Similarly, the prices of petrol will affect the sales of cars or vehicles. Like that, so many variables are there where we have some relationship. So the statistical technique correlation will expresses the nature of relationship and degree of relationship. Nature means whether the relationship is positively correlated or negatively correlated. Positively means both the variables are moving in the same direction. Example, if there is increase in x variable, correspondingly there is increase in y variable. So we can say it is a positively correlated. Negatively correlated, if one is increasing, the other is decreasing. Example, in case of petrol and car. When the prices of petrol increases, the demand for cars, the sales of cars are decreasing. So inversely related, that is called negative correlation. So this technique is called correlation analysis, and the methods, normally we apply three methods: scatter diagram method, and Carl Pearson's correlation method, and Spearman's rank correlation method. Scatter diagram method is only a graphical method where on x-axis we take one variable, y-axis we take another variable. We plot all the pairs. That means at what level of advertisement, how much is the sale. All the data we are having. Simply we plot the data on the graph paper and see the pattern of distribution of points. If the points are moving upward, there is positive correlation. If the points shows a trend downward, there is negatively correlation. If the points are scattered throughout the graph, there is no correlation. Like that. But this scatter diagram method is just a rough method, a crude method of finding out the correlation. The accurate method is Carl Pearson's method. So Carl Pearson's method will give the coefficient of correlation, which range from -1 to +1. The correlation coefficient will never be less than -1, nor it will be more than +1. It will range between -1 to +1. -1 means perfectly negative correlation. Both are moving in the opposite direction and exactly the same percentage. Perfectly negative. Perfectly positive, both are moving in the same direction at the same rate. Perfectly positive. So when the correlation coefficient is 0, there is no relationship at all. And Carl Pearson has given the formula for calculating the coefficient of correlation. And the property is, the coefficient of correlation is independent of change in scale and change in origin. Next. Now, I am going to start the problems on correlation. So before starting the problems, I expect my viewers to have a printout of the problems which I have given in the link under my description. Always take a printout and keep it ready for every video on problems, right? Take a screenshot of the solution of first 3 problems, then I'll explain the problem as well as solution. Come on, first problem I am reading out. Find out the coefficient of correlation between sales and expenses of the following 10 firms. Figures in thousands of rupees. 10 firms data is collected. Two variables are there, sales and expenses. The pairs we are having, for first firm, sales are 50,000 and the expenses are 11,000. Second firm, sales are 50,000, expenses are 13,000. Third firm, sales are 55,000, expenses are 14,000. That in this way, all the pairs of sales and expense are given for 10 firms. Now we are required to find out correlation coefficient. If nothing is given, always we follow Carl Pearson's coefficient of correlation, because that is the most accurate method of finding out the correlation coefficient. Now see here, how to find out the Carl Pearson's. Calculation of Carl Pearson's correlation coefficient. First of all, you need 3 columns. The first column, firm number 1, 2, 3, 4, 5, 6, 10 firms, n is equal to 10. Second, sales. Sales, I am denoting it as X. X values given in the problem, sales are given. Next column, expenses, Y. So X and Y I am treating. Sales are denoted as X and expenses are denoted as Y. Now take the total. Don't draw all these columns. Only 3 columns first of all you should draw, right? These columns depend on whether deviations are taken from actual mean or assumed mean. So that's why until and unless we calculate the mean, we don't know whether deviations will be taken from actual or assumed. That's why don't draw all these columns. First 3 columns we require. Take the total of X, it comes to 580. Total of Y, it comes to 140. That's it. Up to here only you should draw. Then calculate the mean. X bar is equal to summation X by N. Already you are aware about the formulas. Already in the previous videos, measures of central tendency, I have explained. So summation X by N. What is summation X? 580. So 580 divided by 10 firms, N is equal to 10. So 58. 58 is the mean of X values. Now Y bar is equal to summation Y by N. That is 140 by 10, 14. We got the mean of X series and mean of Y series. And what do you observe here? Both the mean is in whole number, not in fraction. We are not getting in points. We are getting whole number. We are lucky. So we can take the deviations from actual mean. Now remember this point carefully. Take the deviations from actual mean because the mean is in whole number. That's it. Now when deviations are taken from actual mean, the formula is this. Carl Pearson's coefficient of correlation. Summation xy. Remember small x, small y. This is capital X, capital Y. Note it. Note it down. Whenever I give the lecture, always keep a notebook beside you and a pen, calculator. Everything should be ready. Seriously, you should watch. Otherwise, casually, if you watch the video, you cannot be able to understand, and definitely independently you cannot do. So whenever I say something, note it down. So this is capital X, capital Y. Here small x, small y. Summation xy divided by summation x square into summation y square under root. This is the formula for Carl Pearson's coefficient of correlation. And this formula will be applied only when deviations are taken from actual mean. That's it. Now small x. In this small x and small y are there. We need a small x. So what is small x? Small x is equal to capital X minus x bar. X bar already you have calculated here 58. So capital X minus 58. What is capital X here? Sales are capital X. So 50 minus 58, you will get minus 8. Then 50 minus 58, minus 8. 55 minus 58, minus 3. 60 minus 58, 2. 65 minus 58, 7. 65 minus 58, 7. 65 minus 58, 7. 60 minus 58, 2. 60 minus 58, 2. 50 minus 58, minus 8. When deviations are taken from actual mean, the total must be 0. You cross check it. Always, not only in this problem. Whenever deviations are taken from actual mean, summation x you must get 0. So take the calculator and check minus 8, minus 8, minus 3, plus 2, plus 7, plus 7, plus 7, plus 2, plus 2, minus 8. If you calculate all, you must get 0. If you are not getting 0, that means you have committed a mistake in calculating these values. Don't proceed ahead. Rectify that mistake. So next y. Small y is equal to capital Y minus y bar. Capital Y is here. Y bar here we have calculated 14. 14 is the mean. So y minus y bar. Y is here. 11 minus 14 minus 3. 13 minus 14 minus 1. 14 minus 14 0. 16 minus 14 2. 16 minus 14 2. 15 minus 14 1. 15 minus 14 1. 14 minus 14 0. 13 minus 14 minus 1. 13 minus 14 minus 1. Again, take the total, you must get 0 always, because we are taking the deviations from actual mean. That's why summation x, summation y, you must get to 0. That point you have to remember always. Now x square. Square the values. X is here. X square. So 8 8s are 64. 8 8s are 64. 3 3s are 9. 2 2s are 4. 7 7 49. 7 7s are 49. 7 7 49. 2 2s are 4. 2 2s are 4. 8 8s are 64. When we square, minus will become plus, because minus into minus will become plus. These are the x square. Now y square. 3 3s are 9. 1 1s are 1. 0 0s are 0. 2 2s are 4. 2 2s are 4. 1 1s are 1. 1 1s are 1. 0. 1 1s are 1. 1 1s are 1. Take the total. X square total you are getting 360, and y square total you are getting 22. Last and final column is x into y. Small x into small y. Here it is small x, here it is small y. 8 into 3, 24. So I have taken 24. And minus into minus will become plus. 8 into 1, 8. Minus 3 into 0, it is 0. 2 into 2, 4. 7 into 2, 14. 7 into 1, 7. 7 into 1, 7. 2 into 0 is 0. Here 2 into minus 1. So plus into minus. Plus into minus will become minus here. 2 1s are 2. So be careful. Even if you commit a small mistake that took plus sign instead of minus, or took minus instead of plus, your whole calculation will go wrong. So be careful. Minus into minus will become plus. Plus into minus will become minus. Similarly, 8 into 1, 8. Minus into minus plus. Now take the total of these x, y, you will get 70. That's it. So we need x square, we need y square, and we need xy. Now substitute. Formula. R is equal to summation xy divided by summation x square into summation y square under root. So 70. Xy is 70. Here it is. Divided by x square is 360. Y square is 22. 360 into 22 under root. So multiply 360 into 22. 7920 under root. After root 88.99. So 70 divided by 88.99, you will get 0.786. This is the Karl Pearson's correlation coefficient. First problem I have explained in detail. So only watching and listening the video is not enough to get the complete command. After listening, after watching, do the same problem without seeing yourself. You see whether you are getting the same answer or not. If you are not getting the same answer, again rewind the video. Again you watch the video where you have committed the mistake. Like this, if you follow my instructions, definitely you will enjoy learning the subject. You will excel in the examination. Now, second problem. Calculate the coefficient of correlation by Karl Pearson's method of the following data relating to overhead expenses and cost of production. Here the two variables are overhead expenses x and cost of production y. Rupees in thousands. Overheads are given, costs are given. Firms are not given, just like the previous problem. Directly given overhead and cost. We treat overhead as x and costs as y. That's it. So calculation of Karl Pearson's covariance, X total is 108 and Y total is 15. You should not make all these columns. After calculating the mean, you calculate the values. One more new point. Here the overheads are given 80, 90, 100, 110, 120, 130, 140, 150, 160. In the previous video, I explained you the property of Karl Pearson's correlation coefficient. One of the property is the coefficient of correlation is independent of change in origin and change in scale. What do you mean by independent of change in origin and change in scale? If you divide all the values by a constant, the R value will remain same. It will not affect. Similarly, if all the values are multiplied by a constant, then R value will remain same. To simplify the calculations, I would have taken the same values over at 80, 90, 100, same values. I could have taken. If I have taken the same values, my calculations will be a little bit difficult because the values are large. So 1 0 is common. Over its 1 0 is common. 80, 90, 100, 110, 120, 130, 140, 150, 160. I can remove 1 0. How I can remove 1 0? Divide all the values by 10. The overheads values can be divided by 10. So 1 0 will go away. The remaining item will become 8, 9, 10, 11, 12, 13. So what will happen? The values will become smaller and calculations will become easier. If I do not make also, I'll get the same answer. If I do also, I'll get the same answer. So what I'm making is simplifying. All the overhead values are divided by 10. That's why I'm getting 8, 9, 10. Otherwise in the problem it is 80, 90, 100 like that. So here, since correlation coefficient is independent of origin and scale, so to simplify the calculations, we divide all overhead values by 10. Explanation I have given. All the overhead values are divided by 10, so these are the values. If I do not divide also, I will get the same answer. But if I divide, my calculations will become simpler. Now, costs are given. As it is, I have taken. Whatever is given in the problem, same thing I have taken. So here, total of X 108, total of Y 153. Don't make this column. First, we'll see whether the actual mean is in whole number or in fraction. So, X bar is equal to summation X by N. 108 by 9. 9 values. 1, 2, 3, 4, 5, 6, 7, 8, 9. 9 values are there. So 108 by 9, 12. Y bar is equal to summation Y by N. 153 by 9. You'll get 17. Again, we got the whole number. Just like the previous problem. The actual mean is in whole number. So we can take the deviations from actual mean just like the previous problem. Small x. Capital X minus X bar. X bar is 12. So capital X minus 12. 8 minus 12 minus 4. 9 minus 12 minus 3. 10 minus 12 minus 2. 11 minus 12 minus 1. 12 minus 12 0. 13 minus 12 1. 14 minus 12 2. 15 minus 12 3. 16 minus 12 4. You must check this must be 0. Before proceeding, you must verify that the total of summation X, you must get 0. When you will get 0? When we have taken the deviations from actual mean. Similar calculations for small y. Capital Y minus Y bar. Capital Y, Y bar. Y bar is how much? 17. So capital Y is 15. 15 minus 17 minus 2. 15 minus 17 minus 2. 16 minus 17 minus 1. 19 minus 17 2. 17 minus 17 0. 18 minus 17 1. 16 minus 17 minus 1. 18 minus 17 plus 1. 19 minus 17 2. Again take the total of small y. You must get 0. So summation X and summation Y, you must get 0 when you take the deviations from actual mean. Now square it, X square. This X, now square it. 4 4s are 16, 3 3s are 9, 2 2s are 4, 1 1s are 1, 0, 1 1s are 1, 2 2s are 4, 3 3s are 9, 4 4s are 16. When you square, minus into minus will become plus. So whenever you square, minus sign will become plus sign. Now take the total of X square, 60. Now Y square, these are the Y values. 2 2s are 4, 2 2s are 4, 1 1s are 1, 2 2s are 4, 0, 1 1s are 1, 1 1s are 1, 1 1s are 1, 2 2s are 4. Take the total, it comes to 20. Now multiply x into y as usual, x into y. 4 into 2, 8, 4 2s are 8, 3 2s are 6, 2 1s are 2. Here minus into plus will become minus here. Here minus into minus will become plus, minus into minus plus, minus into minus plus. But here minus into plus is minus. 0 into 0, 1 into 1, plus into minus will become minus sign. 2 1s are 2, 3 1s are 3, 4 2s are 8. Take the total here 24. xy is the total 24. That's all. We have made all calculations. Simply you substitute in the formula. Carl Pearson's correlation coefficient, exactly same what we have done in the first problem. Summation xy divided by summation x square into summation y square. So xy 24. 60 into 20 under root. 1200 under root. 34.64. So 24 divided by 34.64, 0.693. That is the Carl Pearson's correlation coefficient. Two problems I have explained. Now problem number 3. Calculate the correlation coefficient between height of father and son from the following data. So we have selected the pairs of height of father and height of son. So in the first situation, height of father in inches is 64 inches and height of son in inches is 66. Father height is 64 inch and son height is 66 inch. First pair. Second pair, father height 65 inch and son height 67 inch. Third pair, father height 66 inch, son's height 65 inch. Like that we have taken 1, 2, 3, 4, 5, 6, 7. 7 pairs. Now we are interested in finding out whether correlation exists between the height of father and height of son. So calculation of Carl Pearson's. So you should not draw all the columns in a stretch. Remember, first problem itself I told you, first 2 columns we require. Remaining you just leave the space, make some calculations, decide and then make the column. So first column, height of father x, whatever is given in the problem, same I have copied. Height of son y, I have taken the same. I have denoted height of father as x and height of son as y. Now take the total of x, 469, total of y, 476. Now calculate the mean value, x bar, summation x by n. 469 by 7, 67. Y bar, 476 divided by 7, 68. Again we are very lucky. We got both the means in whole number, just like the previous 2 problems. In the next video, I'll come across where the actual mean will be in fraction. Then formula will change. But here formula is same. So here for 67, 68, mean. Same column, small x. Capital X minus x bar. Small y, capital Y minus y bar. X square, y square, xy. Now, x minus x bar. X bar is how much? 67. Here, x minus 67. 64 minus 67 minus 3. 65 minus 67 minus 2. 66 minus 67 minus 1. 67 minus 67, 0. 68 minus 67, 1. 69 minus 67, 2. 70 minus 67, 3. You must get the total 0 because we have taken the deviations from actual mean. Similarly, y. Y minus y bar, y minus 68. 66 minus 68 minus 2. 67 minus 68 minus 1. 65 minus 68 minus 3. 68 minus 68, 0. 70 minus 68, 2. 68 minus 68, 0. 72 minus 68, 4. Take the total, you must get 0. Summation x, summation y, 0. Square it. 3 3s are 9, 2 2s are 4, 1 1s are 1, 0. 1 1s are 1, 2 2s are 4, 3 3s are 9. Take the total of x square, 28. Similarly, y square, 2 2s are 4, 1 1s are 1, 3 3s are 9, 0, 2 2s are 4, 0, 4 4s are 16. Take the total, 34. Multiply x into y. This is x, this is y. 3 into 2, 6. Minus into minus will become plus. 2 into 1 is 2, plus. 1 into 3 is 3, plus. 0 into 0, 0. 1 into 2, 2. 2 into 0, 0. 3 into 4, 12. Take the total, 25. That's all. Simply substitute the values in the formula. The formula is R is equal to summation xy divided by summation x square into summation y square under root. Xy is 25. X square is 28, y square is 34. 28 into 34 under root 952 under root 30.854. So 25 divided by 30.854, 0.81. That's it. So 3 problems I have explained you in detail. But all the 3 problems are similar because the deviations are taken from actual mean. Same formula I have applied. But in the next video, the formula will change because the actual mean will come in fraction. That I'll explain in the next video. So this is the end of the problem number 3. Inshallah, the next problem I'll take up in the next video.